So the majority of this video is going to be about this LCD from SparkFun. Now, what makes this LCD unique is that it has a AtMega chip built in, which gives it the ability to interface with the microbit using I2C and SPI, and also UART. That is extremely useful because it means that you can interface with far less cables than a conventional LCD. The I2C aspect of it is also very useful because in a later video we'll be discussing an I2C breakout board, which allows you to interface with 6 peripheral devices using I2C with only one I2C wire. So in order to get to the documentation, you just go onto this website, click documents, and then you can just click hookup guide from there. Now, like I said, I'm going to be using I2C to interface with this LCD. So I'm going to click I2C, and then we're going to be using this QWIIC connector. What's really nice about this connector is that you don't need to have header pins connected to the LCD, which will make your design a lot more streamlined. So pretty much all you have to do is connect your power ground and then connect the yellow wire to SC and your blue wire to SD. And then this is a little piece of example code. It's very basic, but writing to the LCD is very simple. The only thing you need to keep in mind is that there's 2 special commands for placing the LCD in setting mode and clearing the display. So I'm going to be basing my code off of that. In order to make the demo a little bit more interactive, I'm going to be basing the code off of the demo from the last video. So if I'm going to quickly just reference that video for some piece of the code, I'll also include the code in the description of both videos. The library that this is based off of is called wire.h, which is a super common Arduino bus library. And let's define the display address, which is set to be at 0x72 in the documentation. So next what I need to do is define some of the variables that I did in the last video. First, we want to define our input locations, and then we also want to make some variables for our input states. So in the setup area, one thing that's different is we want to initiate the wire. So we'll do wire.begin. And then we also want to define our pin modes, which we did in the last video. Okay. We want to begin serial.begin, and that is 9600 baud rate. And then we want to, like I said earlier, clear the screen on startup, and you have to do that with this series of codes that you send. That's it for the setup. Now for the loop, we're going to start off like we did in last video. We want to interrogate all of the sensors so that we can receive their state. Just like that, we're doing digital and analog reads. Now to keep the potentiometer from bouncing around, I'm going to round it to 5. So I'm going to do pot equal to pot, or let's do pot 5 by 5 times 5, and that should round it to the nearest 5. Next, I'm going to define this function, I2C send value, and then I want 3 inputs going in there. So I want the button, I want the switch, and I want the pot. So I'm going to send all those values in there. And then I'm going to add a delay. And it's actually recommended that you update the screen every 200 milliseconds. You can play with that a little bit, but that's kind of the recommended value. So next, I'm going to define this function. I'm I2C send value, and this is the same function that is in the example that's on the SparkFun website. Except I'm passing 3 inputs, but you can pass as many inputs as you'd like. So like I said, this is a very simple, it's very simple to write to this LCD. We're pretty much just going to initiate with those commands that I said before. And then we're going to write all of our data, and so here's the data that we were writing. So we are writing the button, and then writing the button state, switch state, and then this print ln will push to the next line, and then the potentiometer value, and that's it. And then we just need to do wire dot end transmission. Okay, perfect. I'm going to build that, make sure everything's okay. Okay, looks good. I can go ahead and upload that. Okay, perfect. Looks good. As you can see, the screen is printing like we expected. If I click the button will read high when it's clicked. The switch will read high when it's switched, and the potentiometer will increment as it rotates, and it'll increment in steps of 5, and that goes from 1020 down to 0. So everything works as expected. The rate that the screen is updating looks good. There's no flickering. So I hope this sparks some ideas on how the LCD screen can be used, and also proves the value of using I2C with the microbit.